Hello everyone. So in this module we will cover circular economy, design for sustainability and thinking alternatives and innovation. This is module 6 under the course of UN SDGs. So first we will see circular economy. Well, what is circular economy? I think before getting on to that, we need to know what is linear economy, right? So linear economy is that conventional economy in which there was resource exploitation from the nature, you know, resources coming from the natural like a sources, and then it goes to the factory, then it gets manufactured, then it goes on to the transportation, then it reaches to the markets, right, and then it goes to the shops, right, and then from the shops it goes to the household for consumption, to the individual users, to the consumers, and then from here it gets like discarded and thrown to the garbage, dustbins, landfills, etc., and it comes to an end. Okay, this is a typical like a linear economy in which the resource which was taking from this place is not coming back here, but when it does, it becomes circular economy because it is reaching at the end of its life step, it is going back to the place where it has come. Okay, so you are connecting this last like leg, this last segment also, and you are making this go back to its place of origin, right? That completes the circle. That's why we call it as a circular economy, and this one conventional as a linear economy, because it begins at one place and ends at another place. Okay, not at the same place, right? So this is a typical like a difference. We will see this in detail. So this graphic talks about circular economy. You can see from here, collect at end of life. So this becomes the raw material or the resource, then reusing, recycling, etc., making like a green products, making cleaner products, using cleaner production, cleaner energies, better services, and then again. So circular economy actually helps in multiple ways. So in any of these nodes, if you see, this has a form of responsibility and accountability towards the environment, right? It's not trying to pollute as the conventional like a things used to be like, right? So here also, if you see, there is like a recycle, again making use in some other ways, recycle waste, reusing, as it is. If you want to reuse, like for example like these bottled like water. Okay, so this bottle, if you want to reuse it in some ways, okay, or you can definitely recycle it. You bring it to the like recycling facility, and then you kind of you make it another some plastic like item or something like that. And then here we have non-toxic, long life recyclable things. So non-toxic, as we know, like some products mainly like factory manufactured products, since they are composed of several chemical compounds in different proportions. Okay, so chemical compounds usually they have like some kind of impact. They are not friendlier perhaps, or they are like a hazardous to like human health or other like a biological like a things, and etc., etc. So those kind of things go into the toxic like a category. To give some like example, like VOCs, volatile organic compounds. Like if you enter into a freshly painted room, okay, how do you feel? It feels very pressured, like the air is very pressured, and it is going across like your nostrils, and it's putting like some pressure, very strong like that pungent smell, kind of thing, not pungent but very peculiar kind of like a smell, these paints and varnishes and all stuff they actually produce. That is because of like this like a volatile organic compounds. Okay, so since in a freshly painted room the concentration is very high, right? It's a new room, right? So new occupant, they are going to like have it like a more, right? And over the time actually it kind of goes down, but it takes a long time for it to come to like almost nil. Okay, so over a long period of time it takes like to come down, but initially it's very high, then gradually it comes down. Well, if the percentage is more, of course, on the day 0, day 1, it will be like in a very high quantity, and it is not good for the human health, right? It can cause several like respiratory like conditions and things like that, right? Skin irritation, like eye irritation, right? And some more like things, right? But even like if it is like a few months old or over the time, they still like keep on emitting like a sum, right? Well, the ratio here is very small, so we do not perhaps like notice it so much, or we do not feel like bothered like so much. For example, another example of mosquito repellents. Okay, you may have seen like those warnings written on these mosquito like repellents. Okay, like it contains a poison, it is not safe for like touching and direct smelling and things like that. Okay, well, definitely we know it kills like mosquitoes, right? So of course it's a kind of like a poison which like a potency is very high for killing a mosquito, but perhaps that potency is not sufficient to kill a human being, but it doesn't mean it is not harmful, right? It is harmful in perhaps like a lower ratio, like a smaller ratio, right? But it is harmful. But the thing is ki if it is getting accumulated over a long period of time, like a tiny lots of tiny bits, okay, it may give you some like conditions. It may kind of put you into like some like a health like a complications, respiratory conditions and things like that. Okay, so these are all actually product like a categories where it is not that much like a toxic and a direct like a uses, and that's why it is kind of permitted for human uses. Okay, but still there is like a factor of like a toxicity you have to remember. So it's a kind of like a negotiation, how much is permissible and how long you want its exposure and all that. So you can decide based on your own like considerations, like what do you prefer for your own well-being or your family's well-being, right? So if these kind of substances they go into the like atmosphere in the ecology, definitely they have like some kind of impact on the other like living forms, also other natural like elements, also like some of the like compounds they are good enough to spoil like water resources, air resources, soil, right, and all of these. So those you consider as non-toxic. So as economy where like such compounds are responsibly taken care of, that becomes that becomes a part of like a circular economy, right? So these collectively, let's you call them like a green products, where like a consideration is there, right? So reducing environmental footprint, you see this term mentioned over here, because overall like they carry some impact. Okay, so if you cannot bring this impact to zero, but at least you can minimize it and minimize it more and more. Then cleaner production. Okay, so cleaner production means even while producing there should not be like much of impact. Okay, so lesser and lesser the impact, better and cleaner it is, right? So the same thing, for example, conventionally we know like like these coal power like a plants like a thermal like plants where like electricity like a generation like takes place, right? So they used to be like a very high like a polluting like a units, and that's how why actually they were kind of less preferred as the time actually progresses. Okay, now there are other much cleaner like a forms of like energy generation. Well, no energy generation till now has like any kind of impact. Even like windmills and all, also if you see, they like rely on like batteries and like stuff and all that. So some impact even they have, like if you go for like a hydropower like structures and all, where there is like a huge like retention of water, and then the water forcefully flows at the down, and then there are turbines here which are running and electricity getting produced. So this has its own like a kind of impact, and of course nuclear power has its own kind of impact. So it is kind of like a negotiation. Again, it's a negotiation where like how much of like a megawatts you are able to produce in how much of impact. So you need to kind of establish this relation, and go for that negotiated like a threshold where you are minimizing the impact in the maximum of like a power generation, right? So, and again, the form of power generation, that is also important, like air pollution, like a noise pollution, water pollution, nuclear like a radiation pollution, and all of those kind of things. Okay, so it's again a kind of like a big like a negotiation kind of thing. So that qualifies as a cleaner production. Now better service to extend lifespan. So here it means like extending lifespan. For example, if I'm using like a certain product, for example this pen, okay, so this pen is kind of like an object which, if for whatever x long like a duration of time I'm able to use it, the more efficient you can call it, perhaps, like each and every product almost is designed like its life like span also in mind. For example, like automobile industry, if you see, so it is said that typically designed for 15 years plus 5 more years, okay, and once this period is over, 20 years, so RTO is going to kind of like put a ban on that particular vehicle. That means it's time to scrap and send it back, right, for recycling, reusing, etc., etc. That means in this like a 20 years that product comes to its end, okay. But what if there are like other type of consumer appliances, for example like washing machines, TVs, like fridges, etc. They do not go so bad like so easily, right? So if you keep on using them for a longer period of time, for example even furniture like chair, okay, so a simple chair from our grandparents like a time, if you see those wooden chairs, well, it is definitely not good to use like a wood. But if you make an LCA analysis and compare a chair made up of wood and a chair made up of like a plastic or other composite materials, okay, which one is good, okay, so definitely you will be able to find like a kind of impact what these like different materials like exert, and the time span like how long they will be in use, like you can use them, their durability, like, so that thing. So the more and more time, like a grandfather's chair, perhaps it is still there in your home, right? So you can understand like one piece of chair has served for so many decades, right? So but today's like a furniture typically do not last for so many decades, right? Forget about like several decades, they just go bad in few years, right? And they are very difficult to kind of repair also. There are like a different types of material, for example glass and steel, steel to plastic, plastic to aluminum, aluminum to something else, etc., etc. So different types of materials and their joinery brings complication. So you want to simplify it, okay. So this is where like this strategy comes into the picture. These strategies I have discussed in my another course, strategies for sustainable design. Maybe you can refer that like separately, okay. So utilizing those strategies, you can extend the lifespan, and in turn you are saving a new product, right? So that's is as good as like a making or saving like that product from manufacturing, right? So that is the concern where we use this kind of strategies. Now next, collect at end of life, like a remanufacturing. So if it has finally come to its end of life like a stage, then still you can go for like salvaging it, right, or recovering like some like things from it, like metal components. If you see, if it is a pure metal like like a MS mild steel, definitely you can take it out and kind of like recover almost 100% out of this, except some rust and wastage and cutting, etc. Mostly you can recover like up to the highest percentage. Even glasses, if they are not kind of laminated or maybe treated or something else, you can further recover like a glasses also by 100%, right? But some other things, for example nylon, like other upholstery material which actually degrade over time, like leather, PUs, right, etc. Those are the materials which actually degrade over time. So it is difficult, to kind of salvage them and make use of them, right? So and yeah, another point, like alloys, for example, like now automobile industry is kind of like a fanciful like sector where alloys are like now almost every vehicle is having like alloys, like wheels, those rims. Okay, so alloys, like they come with like a very high melting point, very high, like stress and strain taking, like a capacity, right, and all of that, very nice shiny, non like a rusting and all of those kind of things. Well, it has all the good properties, but it makes it equally like hard and difficult to recycle, because since alloys have like a very high melting point, it takes more and more energy. So the thing is ki recycling also is an economic process. You have to keep this in mind, right? Nobody does like any of these works just for charity or for the well-being of environment. There should be some economic motivation also, otherwise nobody is going to take up like these things for like a sake of doing like a good things, right? So it becomes essential that the recovered amount what you are going to like get out of like salvaging these like a components is greater than the energy and amount invested in salvaging it. Okay, then there is only like there is a value in doing and taking up this exercise, right? Otherwise nobody will be like financially economically motivated to do like such kind of things. So as a designer, as a manufacturer, as a engineer, as a production like a manager, whatever capacity you are, or as a student also, you need to keep this in mind while you are designing it, right? Like what happens when it comes to its end of life cycle stage. Okay, so this is how we actually go from circular design to circular economy, right? So this actually ability, this quality which you are weaving, which you are encoding in your design, that your design is going to take care of so and so, like a points what we discussed, leads to circular economy. And economy, like economy means like the whole, all of the manufacturing units, all of the suppliers, all of the users, consumers, buyers, etc., etc. So combining all of them, if they all follow, that economy becomes a circular economy, right? So I hope now you have understood. Yeah, so a very amazing example of like the circular economy, that it is an interconnected economy. Like we saw here, this like cannot stand in isolation. This is definitely related to the like a manufacturing plant, or resources and the usage and all of that, right? So it cannot be stand in isolation. It is always interconnected, and that is the like most amazing beauty of like circular economy and circular like design, right? So you see this illustration over here. It talks about some strategies like reducing the consumption. Like you yourself can take a call whether you really need to buy something. Okay, so the moment you decided, okay, I don't need it perhaps that much, okay, immediately at that moment you have saved one product from being unnecessarily manufactured, right? So this is the way all of us can contribute. Then reusing it, for example, if you have already bought it and then if there is no choice, all right, so in multiple ways, like in multiple ways, like how you can reuse these and all of those, then remanufacturing and then recycling, all of that. And now more details you can see here over here. The benefits, they are given on the both side. So raw material conservation, like conventionally rail like a tracks used to carry these wooden like members, those sleepers, right? And just imagine how many millions and millions of like pieces of like this wood earlier were used on the railway tracks. Okay, so if there is any substitute, definitely nowadays we use concrete based like these like a blocks, these bars, these sleepers, right? So those are used. Byproducts, steel beams, yeah, mostly like almost 100% recoverable. Water, car doors, Then in innovation there are, you know, like a machine tools. If you see like how much they have optimized, you know, like work, you know, so that efficiency, you know, engines, you know, like if you can remanufacture or reuse, like if you see you know, like you know, aeroplanes engine, okay, they are very sturdy and long lasting, you know, like a you know, amazing piece of equipment, you know, machine, which is manufactured with, you know, extreme, you know, like amount of research and innovation and technology, right, and very high precision equipment. If you refer them, you know, separately, it will be, you know, amazing to look at how do they manufacture, you know, like aeroplane engines. Wind turbines, electric motors, you know, office furniture, you know, and then in the jobs, like how do they, you know, like create. So these all, if you see, are, you know, like somewhere related, you know, the efficiency, you know, like reuse, you know, like saving on the packaging materials, you know, saving on the efficiency of the car, you know, like managing the waste, you know, managing the embodied energy, and, you know, like other indirect energy consumptions, etc., etc. So they are all interconnected. Let me read this. A new interconnected paradigm of production and consumption is known as the circular economy. This paradigm has changed and been impacted by various lines of research, systemizing them and partially readjusting them to the problems of the present. So, what were the problems of the present? Like we all know, you know, all of those, you know, like emissions, pollutions, you know, like over consumption, over usage, right, too much of electricity consumption, you know, energy consumption, too much of machine, you know, resource consumption, all of them. And if you optimize all of them together with an interesting, you know, like a interconnection, you know, that leads you to circular economy. This has led to the development of a new circularity based economic perspective. At the same time, it is a circular political cultural proposal because it contradicts the linear create, consume, dispose model. Like in the first, you know, like a slide, second slide we saw, you know, how typically, you know, like a things, you know, like a end, right? They come to a dead end, right? But if you bring back, you know, right here, that's like closing the loop. Okay, so if you are able to close, you know, that loop, this becomes a circular design, circular economy kind of like a concept. Calls for new production methods, of course, new technologies and designs, you know, most importantly design, because if design is responsible, design is kind of, you know, like a conscious enough, you know, you are going to save on all of these, you know, like a things, you know, even more things like, you know, emissions, you know, end of life cycle stage and all of that. So more and more thinking, you know, is going to, you know, make your whole system, you know, like a very, very optimized, right? That's why, you know, more brains, you know, should go into the designing, you know, whatever, you know, assignment or infrastructure project or design project you are doing, more and more, you know, investment should go into the design. The movement of resources is continuously depicted in both the production distribution phase and the consumption phase of the diagrams. Four methods, 1 to 4, are the foundation of circularity in the production distribution phase. We will see on the left side, and are designed to maximize the use of renewable resources and reduce value leakage along the value chain. So you can see over here three principles here on the left side. Prioritize renewable inputs. You know, which one do you want to prioritize? Like there are, you know, several solutions. I said, you know, like a thermal, you know, hydel, you know, tidal, you know, like a nuclear, you know, gas based, you know, many others, right? So or wind, you know, wind ones, or, you know, like solar farms, you know. So which one is most suitable? You need to take up, you know, that exercise separately. There is no universal answer to this question. Okay, so always remember, you know, based on the context and application, you need to take this call and availability of, you know, like a things. What is closer? What is, you know, easily, you know, like a you know, applicable or, you know, like achievable. Okay, so all of these factors actually matter. That's why this decision is essential to take up, you know, project by project. Then maximize product use, recover byproducts and waste, so that, you know, maximum, you know, usability even when it becomes, you know, like a waste. Okay, and you know, those strategies you can see over here. Circular sourcing, okay, as primary material, and then from here, you know, design and R&D, very important, like a stage, the most important perhaps, okay, among all, because here you carry the like a largest potential of saving on to like all sorts of like impacts. Going for sustainable design, resource efficiency, on all sides at the manufacturing stage. Okay, from here you go to distribution, retail, sending to the places. From there it will go to the like a consumers, buyers. Product as a service. Okay, we will discuss briefly in few minutes. Usage and consumption. Okay, at this stage where like you and me as a user get involved. Okay, and then there is value leakage, it says. So that means it is kind of slowly starts losing its value. Okay, when it comes like a closer to the like end of its life. Okay, so how again it can go back. Okay, so from here if you see these arrows start going from this side, this stage and up. Okay, so from here like sharing, visualizing, usage optimization, maintenance at these stages is like the strategies what you can like employ, right? So at this stage in the user's consumption you can go for optimization, right, maintenance, so that it lasts like a longer. If a machine is not maintained, there is a chance that it may collapse or malfunction. Then reusing, like a redistributing, to the maybe other users and people, like for example books. Okay, if you have done like reading, okay, so maybe you can put it in your library. But if you do not want, if you have access of like a books, if you want to dispose it of, better you give it to somebody, because that printed book, okay, is almost like worth like nothing else but like reading only, right? So maybe better you loan it to somebody, or maybe sell it to somebody, or just give it to somebody, or give it to maybe library, or maybe some public reading space where like more and more people will come and read that, right? So that thing. Then refurbishing, remanufacturing at this stage, so if a component has malfunction, maybe it can be refurbished or reused like again in the next product. Recycling from consumption, recycling from manufacturing. At each stages you can go for like such strategies, and this actually completes, if you see here, and this whole like enclosed like steps, kind of this has the potential to maximize the usage of any like a product, any manufactured good. Okay, so now we will come and discuss this one, product as a service. So what is this? Well, product as a service is a concept coming from SPSS, sustainable product service like a solutions. Okay, so what is this? So I'll give you one example. Like if you need washing machine. So why do we need washing machine? Of course to buy, to clean our clothes, right? Do our laundry. So these washing machines, almost, if not every, but every second household, perhaps, I do not know the number, so let me not comment on that, but like households typically have like a washing machines, right? So these washing machines we buy and we keep them in our home as our own like a personal like a product, personal like a uses ka product, and over a certain period of time it develops some snacks, and finally it comes to the like end of its life, and now it's perhaps at a time to discard or like throw it down or buy another one, right? So perhaps 10 years, 12 years, 15 years maximum perhaps. Okay, as a domestic like washing machine ka life age, life duration. So this comes to an end. What could be the another approach? So for that you need to go back right here. What is the need? So the need is to clean the cloths. For that you are buying this machine. So the basic need is to clean the cloth, and that can be satisfied by other means also. Like conventionally there used to be like a washerman, right? There was no washing machines earlier. So you used to give your like a cloths to them. They used to wash and give it back. Okay. So if you go for similar kind of thing, if there is some outsourcing kind of facility, for example, this washing machine itself, well, there is no manual washing anymore. Okay, so machine based washing only. But if this machine is not owned by you, but if it is owned by the company itself, and you are just availing the uses of it like for example 10 cloths, okay, 10x, like rupees or something like that, okay. So pay per use kind of thing. So in that case, the ownership of the machine, lies with the company. Okay. So what changes here? Now these are two different scenarios. In this case, company is the owner, and in this case, individual is the owner. Okay. So what changes? You'll be surprised to learn, like amazingly, these are not two completely different scenarios for the design of this same, like a machine, and it's not the same machine anymore. If it is an individual, like a household based machine, okay, they make it little, lesser sturdy wala, not so industrial grade quality wala, like a machine and all that, right? So that it comes to an end, like in this particular, years of time. Plus, meanwhile, also sometimes intermittently it requires some service repairs, etc., etc. But in this case, since the owner is company itself, they are going to design it differently, because now it's the headache of the company, right? And they are not going to charge you additionally, for its maintenance, repairs, spares, etc., etc. So they will design this machine in a much sturdier, like a way, right? So that it lasts, like a longer. It requires less, like a maintenance and things like that. Okay. So this will definitely go into a industrialized form of, like a manufacturing, and perhaps not just one householder, perhaps like a 10, 20, 30, 50, like a households can use it maybe at a common place. For example, if you go to Western countries, you will see, like such laundry rooms, okay, in common places. You go and use it, for per like a consumption wala, like a cycle. Okay, so the design of the thing, like a changes, because how often we need the machine, perhaps maybe once in 2 days, that may be a typical, like a washing cycle. Okay, so actually in the individual ownership, you do not need it every day, every hour. But if it is designed for industrial use, the same machine, perhaps with the twice of consumption, can serve to 20 families. Okay, so at least you have saved on the, like 18, like such machines, right? So that becomes, like a concept of, like a product as a service. So not the product itself, but you are selling the service. Very famous example of, such things you may be already aware, like, like Ola, and Uber, and, like a such, like a taxi wala companies, where you need not own, like the vehicle. Whenever you want, it is there, right? So that way. Now we'll see on this table at the bottom, prioritize renewable, like inputs. The first at the top we saw, maximize product uses, recover. So initiatives, circular sourcing, sustainable design, resource efficiency. What do they mean? So definitions are given over here. Maybe you can note it down for your reference. Replace finite resources, materials with renewable, bio-based or recycled materials in the production process. Design products, select raw materials that they can be effectively disassembled, reused, repaired and upcycled. Optimize use of raw materials, so minimize waste. Okay, and then the second we have, provide a service in areas that were traditionally sold as products. Increase the product life cycle through repurposing at the end of uses. Share durable assets. Increase performance, efficiency. Purchase and sell second hand or previously owned products. Remanufacture products or components. Waste or byproducts. Recycle discarded materials. So moving on, through sharing, reusing, repairing, remanufacturing and recycling, 6 consumption related techniques, 5 to 10 we saw previously, that reduce value leakage, circulate goods and materials at the peak of their usefulness. When a product reaches the end of its useful life, value is lost since significant byproducts are not collected for profitable reuse. The circular economy prevents value leakage by reusing items and materials rather than discarding them after use, which results in increased value. The idea of industrial metabolism, in which waste is used as a resource for new production cycles through closed circular process, was developed by drawing inspiration from the dynamics of natural ecosystems. Thus, the basis of industrial ecology adopts a vision of industrial symbiosis, which in this instance goes beyond the bounds of industrial systems to incorporate ecological systems and social welfare via analogy of natural systems. Like how natural systems actually work, they are efficient, they do not have like an impact, right? So, like this symbiotic, like a relationship between different elements in the nature. Okay, if we emulate them, in our kind of design and manufacturing sectors, it will bring like a tremendous change. And for that itself, like these 17, like goals were actually framed, and now like we are studying it. So circular design, if you see, has potential to save on like many of these like directly, and perhaps all of them indirectly, like sustainable cities and communities, responsible consumption and production, industry innovation, infrastructure, decent work economy growth. So these are some like a direct like a related ones. How it is related, that we will see, like with the respect to SDG 2. Severe starvation, malnourishment are the focus of sustainable development goal 2, because they continue to be the obstacles. Like we like previously we have covered this, like how SDGs like in that too also, like properly SDG 2 is crucial for the human being. And currently, like like what is the kind of status and different like countries, how good they are. Okay, so with the reference to like that, you can see food shortages and high food prices are a result of a combination of climate related shocks, societal unrest and decreased food production. So both happening simultaneously or concurrently, could be the reasons for how like there may be like a shortage of food also. Like previously we saw how much of percentage of food actually gets wasted. Okay, so all of those things actually further enhance the catastrophe, right? Even though we had food, but we lost it somewhere, it got it wasted, and now there are more and more like hungry mouths to feed, right? So that's a kind of mismatch. For the purpose of decreasing hunger and poverty, enhancing food security, generating employment and enhancing resilience to shocks and catastrophes, agricultural investment is essential. So for meeting food demands, that is not possible, like without agriculture. Okay, so agriculture production, like a stage is the most crucial one, from where this whole actually food, comes from. Food safety includes both the production of food and minimizing food losses along the value chain. To give you a sense of how much food is lost, consider that if global food loss and waste were a nation, it would come in third of the United States and China in terms of emissions. So just like imagine how much of food is getting lost, and how much of impact even that lost food is having. Okay, so it's a kind of a double like an impact.